Hey everybody, I'm Mr. Hartzler, and I want to talk to you about trig functions and solving their equations if we're using inverses. So inverses, if you're one of my Algebra 2 students, we've talked about this before. And I think it's going to be more helpful if I start showing you some examples. So let me share my screen with you, and we'll bring up this whiteboard. There it is. And this is going to be our first example. So we're trying to find inverse. That's what this little 1 up here means, is inverse. So I'm going to circle that. That is telling us that we're looking at inverses. Again, we've done this in my Algebra 2 class before, so you've seen this before. Don't be too frightened, okay? So sine inverse of 1/2 equals an angle in this case. Keep in mind, it usually was the other way around, right? It used to be sine of theta equaled 1/2, and I was curious what that theta was. Well, if I wanted to know what that theta was, well, I actually have to solve for theta, right? And I do that by canceling sine by bringing in inverse functions. So s to the -1, I mean that's inverse, but it kind of works similarly, is going to cancel with that normal sign. And now I have just a theta on the left and inverse sine of 1/2. So that's really how we got to what you see on the left side of your screen. So that's kind of cool. But this is still really just asking for what angle gets me sine of 1/2. So for here we have sine is soch. So let's call this theta, opposite over here over hypotenuse. What creates it so that this is, so our hypotenuse being 2 and our opposite side being 1, what angle makes that situation happen, right? I know that because of the perfect right triangles that we remembered, or sorry, special right triangles, 30, 60, 90, and 45, 45, 90. So we know that this is going to be 30 degrees or pi over 6. If you don't have this memorized, or if this value in here is something other than 1/2, square root of 2 over 2, square root of 3 over 2, 0, or 1, okay, so those are our memorized values. I'm going to write that down over here. Memorized stuff. That's going to be 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And then, of course, the negatives of all of those. Those are the memorized ones. But if not, you can literally type into calculator, okay? I'm going to try and show you how to do that. Let me see if I can stop sharing real quick. Okay. I have my calculator. I'm going to start by turning it on, right? That's down here. Then I think this is all going to be reversed for you guys, but I hit the second button up here, the blue one. Then I'm going to hit sine, which is this one. And then I'm going to type in whatever that number was. In our case, it was 1/2. Did I type the 2? I didn't. 1/2. So I don't know if you can see that in there. There we go. It kind of focuses. Focus. All right. You can pretty much see it in there. Sine to the -1. That's because of I hit second button first. Then I hit enter, and it equals 30. If you try this on your calculator and that does not happen, then we're going to hit mode right here. We're going to come down until radian for you is probably flashing in black. I'm going to go over to degree, hit enter, do it again for good luck, second and mode, or the quit button there. Because sine of 30 is in fact, or sorry, sine inverse of 1/2 equals 30. So that is my degree. That is my angle measurement. So I'm going to share my screen again with you. Where am I at? Oh, backwards with my little track pen here. Okay, up here, whiteboard, cool. So 30 degrees or pi over 6 radians. So I'm a huge fan of radians. Feel free to use radians whenever you want. So that's important. Open up another browser. There we go. So 30 degrees. That is important. There's also this in one other place. So this triangle here, sine is positive in the first quadrant and in the second quadrant. So this angle over here could also be 30. So what gets me all the way over to there? Well, that's going to be 150 degrees. So this is 30 or pi over 6 and 150 degrees, because that creates the same triangle and sine is still positive. And then it's going to be 5 pi over 6 in radians. All right, I know this is a lot, so let's do another example here. So let's save this and clear it all up. Let's look at this one. So this is going to be sine inverse of square root of 3 over 2 equals theta, and I'm solving here for theta. Okay, I don't know what my angle is. First thing I want to do is look at this value on the inside, right? I can always change this if I like to sine theta is equal to square root of 3 over 2. Where is that true? Well, it's a positive number. So I come to my graph, all students talk constantly. So I know I'm in the first quadrant and the second quadrant because, again, sine is positive. So I'm here and here somewhere. Now, what angle, I'm going to look at the first quadrant first, gets me a square root of 3 over 2. So again, this is a memorized value from our little table. Sine of 30 degrees, 45 degrees, and 60 degrees. Sine of 30 is 1 over 2. Square root of 45, or sine of 45 is square root of 2 over 2, and 60 is square root of 3 over 2. So it is this last one, 60 degrees. That tells me this first chunk is a 60-degree mark. And again, I talk about this this little chart in a different video, so go watch that one. That one was 7.2. But then I also, of course, have this angle that comes all the way over to this part. So that is where this chunk is 60 degrees. If I'm 60 degrees short of 180, that means I'm at 120. Okay, I hope that makes sense. So this 120 plus this little chunk of 60 gives me the total of 180. That's how I figure out how I'm going all the way over to here. All righty, so this answer is theta is 120 degrees or 60 degrees. And that is, I'm going to write, I'm just going to do a line. Okay, degrees on top, radians are going to be on bottom. I also would equal pi over 3 and 2 pi over 3. Bottom part is in radians, top part is in degrees. Okay, let us do another. All right, so let's look at this one. What are all the values in radians that have a sine value of, so sine of theta equals 0.85. That's what they're asking here. So just like I showed last time, that could be written as sine inverse of 0.85 equals theta. And what on earth is theta? This one is not a memorized value, okay? Remember, our memorized values are 0, 1, 1/2, square root of 2 over 2, and square root of 3 over 2. So I'm going to turn my calculator on, and at the second button, I'm going to hit sine, and I'm going to type in 0.85, enter, and that gets me right here, 58.212 if I round up, and that is in degrees. So I'm going to change this a little bit, right? I'm going to hit mode on my calculator. I'm going to go down and hit radians, exit that, and I'm going to type in the exact same equation, and I end up with 1.016 radians. I also want to illustrate, right? This is true in a couple of different places. So this is true here and here. And if I go all the way around the circle, back to here, or all around the circle a couple of times over to here. It's true in both of those places. So I have to account for that, right? If I'm at 58 degrees, then that means I'm at 180 minus, I'm going to draw a picture again because I cluttered it up. If this is 58, then this chunk here is 180 minus the 58.212. So let's do that. 180 minus that 58 is going to get me 121.788. And for the radians, that's in degrees. And for the radians, right, it's pi, or 3.14, all the way over to this mark. So I'm short by 1.16 radians. So I'm going to type in the actual symbol pi and going to subtract that answer, and I get 2.126 radians. And I could do a full loop around my circle and end back at that same spot. So let me erase a little bit of this. Okay, let's get these out of the way too, right? Let's clean this up a little bit. So what if I went all the way around the circle 2 times and then I went up to the 58 degrees or the 1.016 radians? Well, I could keep going that many more times around, right? And then end at those locations. So I have to add to all of these 2 pi, okay, so full rotations times the number of times I want to go around my circle, okay? That is true for all of these. Okay, so for all of these things, the answer is 58.212 plus 2 pi times the number of times, or sorry, in this case it would be, let me erase it. Mistakes. 58.212 degrees plus 360 degrees times n, or the number of times I want to reference my circle, or go around my circle. 0.788 plus 360 degrees times the number of times I want to go around my circle. Just like down here, it's 2.126 radians plus 2 pi times the number of times I want to go around. Okay, I hope that's helpful and not cluttering you up a little bit, but let's keep going here. Save this and let's clear it. And let's look at another little word problem, okay? So cosine inverse of negative 1.75 equals theta. Remember, this could be written similarly as cosine of theta equals negative 1.7875, sorry. Okay, right? These are the exact same question written 2 different ways. Now, what's theta in this case? It's my angle. Okay, what angle gets me negative 1.75? My last video, I talked a little bit about graphing cosine and sine, and their maximum values are 1. Their minimum values are negative 1, unless for some reason I'm scaling this up. But I notice in front, there's no other number here, right? This is just a 1, so I'm not scaling it up. This can't happen. There are no angles that make this true. Okay, I cannot finish solving this problem. There's no solution to this problem. Okay, I would write maybe no solution. It's Italian, I think, if I say it like that. So there's no solution here. Now, on a slightly adjacent note, though, right? See that? The trig adjacent. Okay, so cosine inverse of negative 1. Or, right, the same question, worded differently. Cosine of theta equals negative 1. What's my angle? Well, that happens, remember cosine is my x coordinate. That happens when I'm over here. My x coordinate is negative 1. My y coordinate is 0. So this would be 180 degrees. Ooh, lights just went out in my classroom. I've been sitting still too long. I'm going to blinded you guys here too with, I don't know what's giving that glow. Anyway, so 180 degrees or pi radians. And remember, I could keep going around the circle. So let's clean this up a little bit. So it's 180 degrees plus 1 full rotation times the number of times I want to go around. Or it's pi radians plus 1 full rotation, which is 2 pi, times the number of times I want to go around my circle. Okay, so I really hope that was helpful for all of you. I'm trying to make this as simple as I can, but it's really hard if you can't see my face, right? That makes a big difference in all of this. Being able to see me makes it a little bit, oh, it's the window. I think that's what's that big thing is. So hopefully this was helpful. If it was, please click that like button. If you have a comment, if you have a suggestion, if you're another teacher watching this, or if you're a student who has practiced this kind of stuff before and you think that you have a good idea of maybe how I can make this simpler, please let me know. Please tell me that down in the comments. It's been a long time since I've taught Algebra 2, at least this part of Algebra 2. And I'm also not in class right now because we're doing the distance learning thing. So I'm trying this out. Please give me some comments if you think this was hard or easy or what I could do to make this better for you. I really hope it was helpful. Click that like button. Subscribe to my channel. I just have to say that. And Have a phenomenal day. Do math carefully and with enthusiasm, everybody. Bye now.